This is my new mini grow box. I'm making it so I can film a long duration time lapse of very slow growing mosses, lichen and fungus taking over and establishing themselves on the model I made. Hopefully this barren terracotta landscape will grow into a beautiful pastoral scene rich with colour. To help it do that, we're going to be maintaining a constant flow of water through the stream and of course monitoring conditions with a range of sensors, all controlled via Pigrow. In this video I'm going to quickly demonstrate the new install options and show how to set up a LED and a switch. First I'll show you how to install the Pigrow software in the new GUI. We have the Raspberry Pi set up and ready to connect via SSH, so we can just open the GUI and log onto it. Because the Pigrow software is not yet installed, it says no Pigrow config file, so we switch to the System tab and press the Install button. In this dialog box we want to click the Install Wizard. This will guide us through the process. First it's installing the Pigrow code and the required core dependencies. When that's done, you're going to want to select a name for our box. This one I'm calling Sagemoss, a little nickname for my village. The next thing it wants is to enable the Trigger Watcher. This is a tool that allows you to trigger events based on sensor readings. We don't need it right now, but we will be using it later, so let's enable that, and it will run every time the Pi is started up. Finally, it wants to know if we should enable self-logging. There's two options for scripts that collect various bits of system information. They can be useful for diagnosing problems. I'm going to be testing various things on this build, so it will be useful to have some information, but I don't need to worry about it too much, so I just select the basic one for now. Now that's all set up and ready to use, if I press Read System Information, it'll ask the Pi all sorts of questions and display that here. The important one to check is the power warnings, and thankfully we don't have any power or temperature warnings. If you do, then it's likely your USB power supply or the USB cable that's the problem. Surprisingly, it is often the cable that's the issue. Now we've got the Pigrow base set up, I'm going to add an LED and a switch. Eventually I'll be using the LED as a status indicator and the switch to allow me to pause the camera and watering system so I can open the box when needed. But to test them, I'm just going to start by setting the switch to change the LED. First we need to quickly assemble the LED so we can plug it into the GPIO. I'm using a little 3mm blue LED. They're rated between about 3 and 5 volts, so that's perfect for the GPIO on the Raspberry Pi. We do need a resistor to protect the Raspberry Pi though, because without it the LED will draw as much power as it can, which could burn out the chip on the Raspberry Pi. So we need a resistor. For this little one we need about 330 ohms. You could go lower or you could go a little bit higher, but this is a nice safe value generally. And we're just going to wire this to one of the legs, and then we're going to solder that onto the other end of it, so the resistor and the LED are in series, and we're going to put that there so we can plug those into the Raspberry Pi, and that's all we need to do to get an LED working off the GPIO. We will of course protect the connections with some heat shrink. It's always a vital step. I like to twist the leg of the resistor around the long leg of the LED. It doesn't really matter which leg you connect it to, but it helps identify the positive leg later when we plug it in. That gives us a nice strong mechanical connection. Now we just need to join them with solder. Now we can connect the jumper wire in the same way. Don't forget to slide the heat shrink on first. Mine are short, so I need 2 to cover the resistor. We get that soldered together. And the other jumper wire onto the LED's negative leg. I cover this one with a black heat shrink to further remind me which one is the negative later. We heat them up with my heat gun and they shrink nice and tight to protect those wires. With it all together, we just need to plug it in. The positive side goes into one of the numbered GPIO pins. I'm using GPIO 20. The other goes into a ground pin. To set it up, we need to go to the newly added display panel, where we can add an LED. It wants a name, so we call it Blinker, and it needs to know which pin it's connected to. I put it into GPIO 20. Persist on reboot is ticked, and we might as well leave it like that. It just means if the Pi is restarted, it will continue to blink after the reboot. Now we can save that, and with those details stored, we can test it. If I select Blink from the drop down and press Test, my little light starts to flash. Then I can set it at a different speed, and there it goes. If we want to set the LED state using a trigger or a switch, we can use this command. We need it in a moment when we set up the switch, so let's copy it to our clipboard for now. Now we just need to put the switch together. That's much simpler because we don't need a resistor to protect it, and it's got these handy spade connectors we can plug in. I've just made this by getting a jumper wire, stripping the end, putting it to a spade connector and just blobbing it together with solder. So it's got a nice strong connection. We plug these in, and then we just need to plug this. It's a bit stiff, but we can get it in there. You just need to plug that into our Raspberry Pi. I'm going to be plugging it into pin 21 and a ground pin. So these two on the bottom here. So now we can turn on the Pi again and go back onto the laptop. This time we want to go to the sensor panel and press Add Button to bring up the button dialog box. Again, it wants a name. We'll call this one Rocker, and we connected it to the ground and to GPIO pin 21. So if we're sure that's right, we can press Read Button, and it will tell us that the switch is in position 0, and if we switch the switch and read it again, we see that it's now high with a value of 1. Now we need to set the up and down commands. These will trigger when we flip the switch, so for now we're going to use the commands copied from the LED dialog box. Just to test it, I'll put one as fast and one as slow. There's one more thing we need to do though before we can test it. We need to enable the script that watches the button. I'll update this so it's automatic at some point, but for now we need to go through into the cron tab and add it ourselves. So click Add Cron Job and bring up the dialog box. We want the auto run folder and a script called buttonwatcher.py, but we also need to tell it what button, and so down here in the extra args we need to put name equals rocker. We want this script to start every time the Pi is turned on, so select Startup and press Save. Don't forget to update the cron on the Pi, and when we do, it will give us the option to start the script running in the background. We want to do that, and now it's active. If we switch the button, we should see our LED change the rate that it blinks. Perfect. So I get this mounted in a case on top of my model. Have the switch somewhere useful, and the LED where I can see it. I'm also going to wire in a load of water-based sensors. There's a water quality one, a turbidity sensor, and various other bits. This little thing will help me detect any spills, hopefully, so I'll try that out. And I'm going to set up the camera so I can start filming it, and obviously we need to set up the pump so I can get the water flowing through it. I might add a little thing that makes it rain when I choose to, so I'll have a second pump in there. I haven't decided on that yet, but we'll try out various things, get it working, start getting our time lapse done. So like and subscribe for more videos. Thank you very much to my Patreons, to the open source community in general that makes this project possible.